Hi, future doctors. Welcome to the next class. In this class, we will discuss about rolling body. So, rolling body is different. Rotating body is going to be different. So, which is rotating? It will be there only. It is at rest position and it is rotating. Fan is rotating, we will say ceiling fan or table fan. It is rotating. It is not moving from one room to another room. But rolling body it is not like that. It will be changing its position. So bus wheel, bike wheel is going to be rolling, we will say. We cannot say rotating. If it is rotating means you will be there only. Understood? So that is the difference between rolling body and rotating body. So it is the combination of both translational or linear plus rotational motion. How we are going to explain means if an object is only rotating, only rotating there, then its velocity of center of mass is going to become 0. So at A, velocity is going to be, if it is rotating like this clockwise, this is going to be B. At B, this is going to be B. At C, this is going to be B. At D, this is going to be B. But velocity of center of mass is going to become 0 because it is only rotating here on rotating body. Velocity fan is rotating body, center of mass will be always 0. Therefore, we are saying it is at rest position, but it is rotating. Always tangent gives the direction of velocity. Next, plus this is linear or translational motion or linear or rectilinear motion, translational motion. So at the time, its center will be velocity of center of mass will be moving with velocity v. So what is the velocity of A? It is also moving. What is the velocity of B? It is also moving. If it is moving right side, the velocity of particle C v, velocity of particle D, that is also v. See, this is linear motion. So this body is going to be moving linear. Combination of translational and rotational, otherwise linear and rotational. We are calling it as rolling body. So now it is rolling and moving. At the time, so velocity of center of mass is going to be, here it is 0, here it is v. Therefore, velocity of center of mass is v. Now what is the velocity at point A? So A, if you are taking, this is V, this is V. Therefore, V, V. What is the resultant of this? This is going to be root 2V. Root 2V. Resultant of V and V. So what is the velocity at B? Velocity at B. So one is left side, another one is right side. Therefore, at this position, velocity at B is 0. Which is contact with ground, that point velocity is going to be 0. You can take anti-clockwise or clockwise, you will be getting always which is touching ground, its velocity is going to become 0. Now velocity at C, see here, one is upwards, one is right side. Therefore VV, again you will be getting root 2V, correct? So this is V, this is V, finally you got root 2V. Here and here you got same velocity at A and C. Next, velocity at D. See here, both are in same direction. So V, V. So final answer is going to be 2V. So at top position, velocity is more. At bottom point, velocity is going to become 0. At horizontal position, it is having same velocity. Now, combination of rotating and linear or translational is going to be equal to rolling body. This is going to be equal to rolling body. Now, what is the kinetic energy of rotating body? Rotating body kinetic energy is nothing but half I omega linear of m v square. This is nothing but kinetic energy of rolling body. Total kinetic energy of rolling body they are going to say. Total kinetic energy of rolling body is always equal to half I omega square plus half mv square. Very, very important equation. And I we are going to write m k square. And what is the relation between linear velocity and angular velocity? V is equal to r omega. Then omega is v by r. If you substitute both here, of I is nothing but m k square. Omega is nothing but v by r whole square plus half mv square. If you are taking half mv square common, so if you are taking half m v square common, here k square by r square plus 1. This is the total kinetic energy of rolling body. For this half mv square, you are going to get extra 1 plus k square by r square. You can remember this by having specially this 1 plus k square by r square with one symbol beta. Some people will write different names, but you can remember like that also, of mv square into 1 plus k square by r. This is the total kinetic energy formula. Now, if ring is rolling, what is its, if ring is rolling, what is its total kinetic energy? So, if ring is rolling means axis of rotation will be like this. Therefore, passing through its center perpendicular to its plane. Did you remember? If whenever it is rolling, passing through its center perpendicular to its plane. At the time, what is the moment of inertia formula? I is equal to m r square. If you compare with I is equal to m k square, in place of k what will be there? In place of k r is there. In place of k square r square is there. So total kinetic energy of ring is going to be half mv square into 1 plus r square by r square. Then what you will get? Half mv square into 1 plus 1. So 1 plus 1 is nothing but 2. 2 to cancel. Therefore, kinetic energy of, total kinetic energy of rolling ring is going to be m v square in terms of mass and linear velocity. Like the disk they may ask. If disk is rotating, what is the disk formula for this? Mr square by 2. Moment of inertia of the disk is mr square by 2. At the time, k square is going to be, if you compare with mk square, in place of k square you will get r square by 2. So here you can substitute, then you are going to get total kinetic energy of the rolling disk. Like that, rolling hollow sphere, rolling solid sphere we can get. But finally, try to remember this equation, total kinetic energy of rolling body is going to be. Now we will see for disk. Total kinetic energy of rolling disk. What we said, k square r square by 2. Substitute here. So directly I am writing half mv square 1 plus r square by 2 means what you will get here? 1 plus 1 by 2. Then, so half mv square 3 by 2. So 3 by 4 mv square. So uh, what is the ratio of total kinetic energy of the rolling disk and the rolling ring they may ask? At the time, 3 by 4. If they ask reverse, 4 is to 3. Like that, they may ask the question. Next, total kinetic energy of hollow sphere. So what is the hollow sphere moment of inertia formula? Hollow sphere is 2 by 3 m r square. Therefore, if you got one idea, whenever k square is coming, 1 we got. Whenever r square by 2 we got, whenever r square by 2 is there, we got in place of that 1 by 2. Now here 2 by 3 is there. Therefore, half mv square Directly I am writing 1 plus 2 by 3, because in place of k square if you compare, what you are going to get? K square is 2 by 3 r square. Substitute this k square in this equation. Then what you are going to get? 2 by 3 you are going to get. So 1 plus 2 by 3, what you will get? 5 by 3. So 5 by 3 into 2, 6. 5 by 6 m v square. Like that, total kinetic energy of solid sphere of mv square 1 plus, what is the solid sphere moment of inertia formula? Solid sphere moment of inertia is 2 by 5 mr square. Therefore, what you will get here? 2 by 5. 2 by 5 means 7 by 5. So 7 by 5 into 2, 7 by 10 mv square. Maybe next year they may ask what is the total kinetic energy of rolling body of both hollow sphere and solid sphere. So 5 by 6 by 7 by 10. You have to divide. Maybe NYQ, next year question. We were discussing NYQs. So we have to assume those questions. Then only we can solve whichever they are going to assume in your final exam. So this is about rolling body total kinetic energy. And one of the year they asked what is the velocity at P and Q, where it is more and less, VP. Here B and D we took. Velocity at D is greater than velocity at B. That question also one of the they asked. Next, on inclined plane of these objects are rolling. This is on horizontal surface rolling. Then how velocity, time, acceleration formulas will be changing. So we will see in our next class.